So, welcome back student. Today we will be trying to explore you another strategies, topological strategies. Now, if you see the earlier lectures or the very beginning lecture, we said we will basically try to have a 6 different strategies, 6 strategies through which we will try to explore you different kind of disconnection based strategies. We said initially we talk about transformation, second is starting material, third is functional group. These strategies we have discussed in detail. Number 4 we have just talked about symmetry based strategies, and number 5 comes your topology based strategies. Now, topology is a very unique terminology, is usually used in a topology was often used in the particular field of geometry or mathematics, but how this topology can be used or how topology can be used in the field of organic synthesis we will next talk about. Topology basically means that if you having a cyclic structure in your given molecule, cyclic structure. Now, this cyclic structure can give you a nice topology or nice geometry in the target molecule. Let us say for example, I will give you a few interesting cyclic structure. Now, this structure is basically a and B ring are fused together. Now, if I now draw a structure of this, that 3 rings are there. So, where A, B are linearly fused, but A, B this ring is fused angularly with the C ring. So, C is basically fused linearly with the B, but is fused with angularly fashion with the AB ring, angularly fused. So, this kind of interesting topology will be always there in a target molecule, and normally in the nature you will find that this kind of topologies are very much existing. A unified topology is your bridge structure. Bridge structure has a unique topology, because you are having a core cyclohexane ring and then in top of that you are having a bridge. This also bridge structure gives you a very unique topological features, bridge structure. So, what I am trying to explore throughout this lecture content, I will try to give some terminology, that what are the different kind of ring structure known in the literature and how these compounds are given their nomenclature. So, initially I said these 2 rings A, B having a unique topology, but these are basically can call it as a directly joint. Now, for this kind of topology, if you have to do a disconnection, you can simply do a disconnection through this connecting bonds. This is one of the best way to do it. So, if you are having a required polarity concept, that you can do a simple plus minus carbon carbon bond formation, this could be a good way of disconnection. Otherwise, other things are also basically preferred. If you make any of this ring like A, and then you can put a this kind of structure which gives you this ring, and this bonds will give you the central B ring, or in the other hand, if you having a B ring as a starting material, you just try to do the same way minus minus, but here you basically need a 3 carbon unit. So, in this way also you can do this ring construction. So, these are the some of the usual guidelines, but definitely as I said there are no straightforward guidelines for this kind of molecules. Now, this is one of the interesting topology. There are topologies which, let us say this topology. Now, this molecule is a bicyclic molecule and that particular topology is named as spirocycle, the spirocyclic molecules. Now, for spirocyclic molecules there are some terminologies which you need to know. For spirocyclic molecules they have a common carbon atom and the bond which was just originated are naming in a different way. This particular bond is named as E, 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 E. Now, E basically stands for the terminology named as exendo. Now, what is exendo? Exendo means that this E ring is endo to the right hand side cyclopentane ring, okay, but is exo to the left hand side cyclopentane ring. So, this is A and B. So, there are 4 bonds E1, E2, E3, E4. So, this E1 is endo to B ring, but exo to A ring. So, these are bonds are named as exendo bonds. There is other terminology named as OE or off exendo. Now, off exendo means that the bond which have been generated from the exendo bonds. So, this is the off exendo bonds, this is the off exendo bonds, this is a off exendo bond, this is the off exendo bonds. Now, for strategical guidelines, exendo bonds can be a good point of disconnection as well as off exendo bonds. So, both the bonds basically can be a good strategical point of disconnection, and we probably in the next few examples we will talk about how this exendo bonds and off exendo bonds can be a strategically disconnected. You can also have a topology which I have already discussed. Now, this ring or this bond which is common to both the rings is called fused bond, fused bonds. Now, fused bond, if you want to disconnect this kind of molecule, the fusion bonds cannot be a good strategically disconnection, cannot be a good strategic disconnection, because fusion bond is very difficult to construct disconnection. Now, in those cases you basically have to think about, you can take any of this primary ring or any of this ring as your core structure, either A or B as a starting material. Then these other bonds, so which are the bonds? These bonds are basically exendo bonds, exendo bonds. So, earlier I said exendo bonds can be a good strategical disconnection. So, basically you can now think about having this kind of disconnection or this kind of disconnection to make a cyclopentane ring here or a cyclohexane ring here. So, this gives B, this gives A. So, this is the point, the fusion bonds you probably never touch it, that is a usual way of doing the disconnection, is a usual rule. Now, for bridge structure I say the bridge structure is a very unique topology like this. This is named as 2 to 1, because 2 carbon here, 2 carbon here is 1 carbon. So, if you like to write or if you like to draw the structure in this way, you say this is this. Eventually, for bridge structure also probably the bridging bonds is not a good point of disconnection. Now, probably we all of you have known couple of reactions which gives you a very familiar disconnection of bridge system. The best way always we know 4+2 cycloaddition reaction. Now, what we do in this reaction? you react with a diene and a dienophile. Now, this 4 plus 2 cycloaddition reaction basically makes this carbon carbon bond, this carbon carbon bond. Now, these carbon carbon bonds are basically not bridged bond, you are making this bond. Now, this bridged one is basically this methylene. So, I said bridged bond cannot be disconnected. So, like you can have a other disconnection for this molecule, you keep the core cyclohexane and let us say you put a X group here, a minus group here. So, I am saying that okay, this minus can attack here to give you a bridge structure, like you basically connect here. I said there are some question marks you cannot have, because this in reality these are not a close proximity group, these groups are little bit far apart. So, in those cases this is not a good strategic disconnection. So, these points you need to always consider. And then there are other rings which are also having unique topology. I said there are rings something like this. Now, ring A and ring C, these are called NDL or not directly linked, not directly linked, because you see A and C in between there is a B ring, but these are not directly linked, you have methylene things here. Okay. So, this linearly fused tricycle, then you will find the some other topology. So, ring A, ring C. Now, you see the ring A and C is directly linked. So, this is also a good point that A and C are directly linked. So, sometimes the rings are directly linked, probably this is a good strategic point of disconnection. You have this A, so which is now give you the disconnection something like this part is there, and then so if you have A ring and C ring, you can basically construct this carbon carbon bond through this. So, this could be a good strategic point. Sometimes rings are having a common bond altogether, like this kind of structure, this kind of topology. ABC rings are basically we can call these rings are contiguous. Contiguous means like this is the particular thing that this point is common to all the ring, and these rings are named as contiguous ring. Now, contiguous rings are also you will find many natural products which is having this kind of contiguous structure. Now I will try to give you some structural information on different kind of topological based or topologically distinct molecule in the natural products. Now, eventually you will find that this one of these class of molecule are named as triquinane, which are basically naturally occurring compound. The quinane basically stands for cyclopentane network, and tri means 3 cyclopentane network, and triquinanes always have a very unique topology, means their ring structures are very unique. Few structures already we have talked about. Now, I am saying this is a linear triquinane. Linear triquinane means there are 3 rings A, B or C are basically linearly fused. So, linear triquinanes, and there are many natural products based on this kind of core structure. Then there are angular triquinane. You see, angular triquinanes will be something like having this structure where ring A and B are linearly fused, ring C is angularly fused, is called angular triquinane. Now, definitely those are not hydrocarbons, you have a different functional groups attached to this particular ring carbons, angular triquinanes. In addition, there is another interesting structure which I have already discussed, is called propylene, where you are having a common bond which is common to all the three rings, ring A, ring B and the ring C, and there are compounds. This framework is basically named as Modifane framework, and if you remember the symmetry based strategies, we talked about such molecules like modifanes. Now, there are a large number of natural products which basically having this kind of structure. So, linear triquinane, angular triquinane, and this kind of triquinane are named as propylene triquinane, where a propylene structure is definitely there. Now, their retrosynthetic disconnection as well as their synthesis is very complex, we probably won't discuss all of the things in very detail. I will try to pick up very simple examples while find that how this kind of compounds can easily be made. Sometimes you may have a molecules like this, where a aromatic nucleus was fused with another ring, and in those cases your strategy should be always follow that you start with a aromatic compound and then make this bonds which is basically exendo, or you can make these off exendo bonds. So, you always start with a aromatic partner and then you do the disconnection of exendo bonds or off exendo bonds, but never ever do the other way, means you start with a cyclohexane thing and then you are saying that I will be trying to disconnect here to construct the aromatic ring at a later part. This is usually not recommended, because aromatization is a bit difficult scenario. Sometimes you can do it, but normally it is not recommended, because aromatic precursors are easily available and you can think about making these molecules quite easily. So, now what we are trying to do, we will try to explore this. I said exendo bonds and off exendo bonds are often a good point of disconnection. So, we will try to take an example and we will figure it out how this strategy is valid. I will give you a spirocycle molecule as a target molecule. You see the molecule is 6-member ring is fused with a 5-member ring. One end you are having a benzyl appendage and another end you are the cyclopentane is also kind of functionalized. Now, if you now see the disconnection or this strategically point of nomenclature, this is exendo, exendo, exendo and exendo, and you have this off exendo, off exendo. Now, I always say that off exendo as well as exendo bonds are good point of disconnection. So, simple disconnection of this molecule probably will give you a this kind of structure. And I say that this off exendo bonds, or this is not a off exendo, this is basically a appendage. This appendage can be constructed through a vinyl copper lithium based Gilman. Okay. Now, what I am saying that now you are having a alpha beta unsaturated ketone. So, this probably can be easily made through your. Now, this bond is becoming a off exendo bonds. This bond is your off exendo bonds. Now, I am saying that this off exendo bonds you can easily prepare if you having a this CHO and this CH2 CO CH3 through a intra aldol FGI. So, intra aldol FGI. So, what basically you made? You make a new off extendo bonds. So, we said off extendo bonds are good point of strategic disconnection, good point of strategic disconnection. So, now you can basically see how this rule is valid. We are basically making off extendo bonds, fine. Now again you do the retro for this molecule and then you will find how we can further disconnect it. So, you have to basically bring the aldehyde at one end and then you are saying that we will be trying to do this kind of oxidative cleavage to bring this aldehyde. Now, this was very judiciously or very cleverly done. Now, the next retro will be clearing your all the doubts. We are now saying that if you having this compound, you can do another round of vinyl copper lithium through a Gilman reaction. Now, what bond you are basically making? This bond is basically a extendo bonds. So, you are basically making a extendo bonds. So, extendo bonds are also good strategic disconnection. We earlier said extendo as well as off extendo bonds are good strategical disconnection. So, we are just trying to follow the terminology and now we are now simplifying the structure through this and here BNO C double bond O. Now, we are saying that if you can do a Wittig reaction with this you make this bond. Now, this bond after the final transformation this bond also become to a extendo bonds, isn't it? So, all the throughout the retro we basically disconnected through a extendo as well as off extendo bonds a disconnection. Now, let us do the forward synthesis of this molecule to visualize the entire pathway. So, starting material is this one. First you do a Wittig reaction with this Wittig salt. So, you basically generate the alpha beta unsaturated ketone. So, what you make? You basically make a new extendo bonds. Now this is bond is not extendo bond, this is exocyclic bond, because we did not make the cycle or cyclic structure. Now, we are saying you do a vinyl copper lithium, that will basically give you the this. So, initial extendo bonds was made, you are making another extendo bonds. Okay. Now, this bond in this form is not extendo bond, it is a exocyclic bond. Now, you are doing a oxidative cleavage by sodium periodate and osmium tetroxide mediated dihydroxylation A and B, or you can do a simple ozonolysis. So, what you will be now getting? You basically now get a CHO and CH2 CO CH3. Now, I am visualizing it can be connected through this intramolecular aldol reaction. So, once it closes, these bonds become extendo, this bond become extendo, and the newly created bonds become a off extendo. So, that basically highlights the main thing. So, now see the initial formed bond is a extendo bonds, this bond is a extendo bonds. Now, this one basically a off extendo bonds. So, now you complete the synthesis by doing a again another round of vinyl copper lithium, and then you will find that you have this BNO and you get this spirocycle with these appendages. So, this was basically a nice strategical disconnection of a topologically simple molecule. This topological is basically a spirocycle molecule. Now, if you try to go back to our earlier thing, if you remember earlier we talked about synthesis of this kind of spirocycle molecules through a pinnacle rearrangement. We say that these compounds can easily be made through pinnacle rearrangement of these things. Now, if you are now taking this as a mechanistical perspective, initial what you do, you basically generate a carbonium ion here by water elimination. Now, actually the rearrangement takes place here. Now, this basically migrates, and what it will give? It basically give you the six member things here, and then it basically collapses to give you the carbocation. Now, actually this cannot be a simple exendo disconnection, as I said, because this bond is exendo, this bond is exendo, this bond is exendo, this bond is exendo. But the migration also gives you the hint, because one of the particular bond which is initially endo to one ring is basically migrating, migrating. So, the bond which is initially a directly connected bond, so directly connected bond is now becoming a exendo bonds. So, the earlier one, once we said the pinnacle rearrangement, in two sense is not a exendo bonds disconnection, but you can also figure it out. We are basically going through the disconnection through a exendo fashion. When the exendo bonds are mainly created, like this case we said this is a directly linked bond, Now, once this goes up, one of your bond which is endo to this ring is basically migrates. Now, endo to this ring is basically migrates. So, then this directly linked bond is becoming exendo, is not it? This directly linked bond is becoming exendo. So, our disconnection is basically centered through a disconnection is always focused through exendo bonds, and that was usually preferred when you have a spirocycle compound. Now, we will be just trying to give you one simple bridged bicycle system. The topology was little bit difficult. It is like a box like molecule, you have a cyclopentane bridged here, and in this bottom half you are having another topology. Now, as I said, the bridge structure probably you cannot do the disconnection, and normally for bridged kind of compound the cycloaddition reaction or this particular bond disconnection was always preferred. So, for this one, if you do a disconnection and you make sure that everything was in perfect shape, you probably have a intramolecular disconnection. Now, this compound is basically a cyclopentadiene derivative where you have a properly substituted pattern. So, these things can judiciously be done, but as I said this compound may not be very easy to synthesize because there are certain issues involved. Anyway, we will try to focus it out little bit more when you talk about one another multicyclic molecule in the next lecture, and we will try to figure it out that ex-endo bonds as well as off ex-endo bonds are always a good point of disconnection when you are having a spirocycle topology or related topologies. So, we will continue our discussion for this topologically distinct molecule in the next lecture. Till then, have a good time and goodbye.